Pythagoras of Samos remains a figure shrouded in mystery and legend. We know he was born around 570 BC on the Greek island of Samos. His early life is a tapestry woven from fragments and speculation. Some accounts claim his father, Menisarchus, was a gem engraver. Others suggest he was a wealthy merchant. Regardless of his lineage, Pythagoras received a comprehensive education. He delved into philosophy, music, and mathematics under the tutelage of local scholars and priests. These early influences ignited a thirst for knowledge that would shape his destiny. His inquisitive mind sought wisdom beyond the shores of Samos. This yearning for enlightenment would lead him on a remarkable journey. He would become a seeker of truth in distant lands. Driven by an unquenchable thirst for knowledge, Pythagoras embarked on a series of transformative journeys that would shape his understanding of the world. He ventured first to Egypt, a land steeped in ancient wisdom and mysteries that had fascinated scholars for centuries. There, he immersed himself in the teachings of Egyptian priests, delving deeply into geometry, astronomy, and religious rituals that were integral to their culture. He absorbed their knowledge of triangles and the practicalities of surveying, which were essential for constructing their monumental architecture. From Egypt, Pythagoras' quest led him eastward to Babylon, a center of learning and innovation. This Mesopotamian civilization boasted advanced mathematical traditions that were unparalleled at the time. Babylonian mathematicians had developed sophisticated arithmetic and algebraic techniques which were recorded on clay tablets. They could solve quadratic equations and were familiar with the Pythagorean relationship long before it was named after him. Pythagoras spent years in Babylon, immersing himself in their mathematical knowledge and astronomical observations, which expanded his understanding of the cosmos. Some accounts suggest that Pythagoras' travels extended even further eastward to India, a land rich in spiritual and intellectual traditions. Although evidence is scant, it is plausible that he encountered Indian mathematicians and philosophers who had their own advanced systems of thought. This exposure to Eastern thought could have influenced his beliefs in reincarnation and the interconnectedness of all things, ideas that were central to Indian philosophy. Pythagoras' travels were more than geographical journeys. They were profound intellectual odysseys. These journeys exposed him to diverse cultures and schools of thought, each contributing to his evolving worldview. These experiences broadened his horizons and shaped his unique philosophical and mathematical perspectives, leaving a lasting legacy on the world. Upon his return to the Greek world, Pythagoras settled in Croton, a Greek colony in southern Italy. There, around 530 BC, he founded a philosophical and religious school known as the Pythagorean Brotherhood. This secretive society was more than just a school. It was a way of life. The Pythagorean Brotherhood advocated for a life guided by reason, virtue, and the pursuit of knowledge. Members lived communally, sharing their possessions and adhering to strict rules of conduct. They believed in the transmigration of souls and followed a vegetarian diet. Central to Pythagorean thought was the belief that numbers held the key to understanding the universe. They viewed numbers not merely as abstract symbols, but as the fundamental building blocks of reality. This profound reverence for numbers permeated every aspect of their philosophy and way of life. The Pythagoreans believed that the universe was governed by mathematical principles and that numbers were the language of the cosmos. Each number held a specific meaning and significance. For instance, the number 1 represented unity and the origin of all things. The number 2 symbolized duality and the division between the physical and spiritual realms. The number 3, being the sum of 1 and 2, represented harmony and balance. 4 as the product of 2 times 2 signified justice and order. The Pythagoreans developed a complex system of numerology, attributing mystical properties to numbers and their relationships. They saw numerical patterns in geometry, music, and astronomy, further reinforcing their belief that numbers underpinned the very fabric of existence. Section 5. The Pythagorean Theorem and Beyond. This section delves into the profound impact of one of the most famous mathematical principles in history. Pythagoras is best known for the theorem that bears his name, a theorem that has stood the test of time and remains fundamental in various fields. The Pythagorean theorem states that in a right-angled triangle, the square of the hypotenuse, the side opposite the right angle, is equal to the sum of the squares of the other two sides. This simple yet powerful equation has been a cornerstone in the study of geometry. This fundamental geometric principle has had far-reaching implications in mathematics, engineering, and physics. Engineers use it to design structures, while physicists apply it to solve complex problems. While the theorem may have been known in some form before Pythagoras, he and his followers are credited with its first rigorous proof. This proof laid the groundwork for future mathematical discoveries. This theorem is a cornerstone of geometry, providing a foundation for understanding the properties of right-angled triangles and their applications. It allows us to calculate distances and understand relationships between angles and sides in right triangles. This is crucial in fields like architecture, where precise measurements are essential. The Pythagorean Brotherhood made significant contributions to other areas of mathematics, including number theory and geometry. Their work extended beyond the theorem itself. They explored the properties of perfect, amicable, and figure-eight numbers. Delving into the fascinating world of numerical relationships and patterns, they delved into the concept of irrational numbers, such as the square root of 2, which challenged their belief in the absolute nature of whole numbers. This exploration opened new avenues in mathematical thought and understanding. Section 6. The music of the spheres. The Pythagorean fascination with numbers extended to the realm of music. They discovered that musical harmonies could be expressed through mathematical ratios. By experimenting with string lengths and ratios, they found that pleasing musical intervals corresponded to simple numerical relationships. For example, they observed that an octave was produced by plucking a string and then plucking another string half its length. This 2-to-1 ratio became the foundation of the musical scale. They identified other harmonious intervals, such as the perfect fifth, 3-to-2, and the perfect fourth, 4-to-3, all derived from simple numerical ratios. This discovery led the Pythagoreans to believe that music was not merely an art form, but a manifestation of mathematical principles. They posited that the universe itself was a harmonious symphony, with celestial bodies moving in accordance with mathematical ratios, producing a celestial music known as the harmony of the spheres. Section 7. Harmony in the heavens. The Pythagorean concept of the harmony of the spheres extended their mathematical principles to the cosmos. They envisioned the celestial bodies, the sun, moon, planets, and stars, as moving in circular orbits around a central fire. Each celestial sphere, they believed, emitted a unique sound based on its size and speed. These sounds combined to create a harmonious celestial music, inaudible to human ears, but perceptible to the soul. While this concept may seem quaint today, it reflects the Pythagorean conviction that the universe was ordered and harmonious, governed by mathematical laws. This idea had a profound impact on ancient cosmology. It influenced philosophers like Plato, who incorporated the concept of the harmony of the spheres into his philosophical system. It also inspired astronomers to search for mathematical relationships in the movements of celestial bodies. Section 8. The legacy of a master. Pythagoras' influence on Western thought is immeasurable. His teachings have permeated various fields, leaving an indelible mark on philosophy, science, and mathematics. Although no original writings attributed to him have survived, his ideas, disseminated through his followers, have resonated through the ages. His disciples carried forward his teachings, ensuring that his wisdom was not lost to time. His emphasis on the importance of mathematics laid the groundwork for the development of Western science and philosophy. The principles he championed became the bedrock upon which future scholars built their theories and discoveries. The Pythagorean Theorem remains a cornerstone of geometry, taught in classrooms worldwide. This theorem is not just a mathematical statement, but a testament to the enduring power of logical reasoning. His exploration of musical ratios laid the foundation for the development of music theory. By understanding the mathematical relationships in music, he bridged the gap between art and science. His concept of the harmony of the spheres, though now considered outdated, reflects a profound belief in the order and harmony of the universe. This idea inspired countless astronomers and philosophers to seek a deeper understanding of the cosmos. More importantly, Pythagoras' enduring legacy lies in his unwavering conviction that the universe is comprehensible through reason and mathematics. This belief has been a guiding light for thinkers throughout history. This belief has driven scientific inquiry and philosophical exploration for centuries. It has inspired generations of scientists and philosophers to push the boundaries of human knowledge. His legacy is not just in specific theorems or discoveries, but in the spirit of inquiry he embodied. Pythagoras taught us to question, to seek understanding, and to find joy in the pursuit of knowledge. He taught us to seek patterns, embrace logic, and find beauty in the language of numbers. His teachings continue to inspire and challenge us, reminding us of the profound connections between mathematics, philosophy, and the natural world.